Thank you. So yeah, hey, I'm Rob. I'm here to talk to you today a little bit about the state of WebRTC. Before I do that, just a tiny little bit about me. I describe myself as a digital tinkerer. It's basically because I couldn't find another term to describe what I do. Effectively, I just play with new technologies, see how far I can push them and what I can make with them. At the moment, this tends to be JavaScript. It's pretty much been my hobby for all I can remember. And that sort of led me into doing technical evangelism for Mozilla, which I left back in January. And during that time, I was working on things like HTML5 games, Firefox OS, the evangelism of it, not actually building it, and just talking about web technologies in general. So I was always ingrained in what's happening on the web. Also wrote a couple books, so wrote Foundation HTML5 Canvas, also co-authored a book on HTML5 games as well. And I'm just currently taking the time out to work on personal projects, such as Busy Cities. So this is an experimental project that uses WebGL to bring real-world cities to life in a browser in 3D. So this is using like open data from geographic services in the UK to like do building heights and outlines and stuff like that, and then overlaying things from OpenStreetMaps and all sorts of other places like London Underground data and things like that. So that's kind of what I get up to in my spare time. But you're here today to hear about WebRTC, so let's get into that. So just before I sort of touch on it a little bit further, who here has actually used WebRTC so far? Put your hand up. Barely anyone. OK. That's as expected. Very, very, very few people. So WebRTC is a peer-to-peer communication technology for the browser. As described on the sort of webrtc.org site, it's a free, open project that enables web browsers. It enables them with real-time communication capabilities via simple JavaScript APIs. Quite wordy. I describe it as being like Skype running in the browser, sort of. It's a lot more than that, and it's barely scratching the surface to describe it in that way, but it's a good way to sort of at least start off. It's also being produced as a W3C specification, supported by Google, Mozilla, Opera, and many other people as well. It's currently in going through the editorial process, so it's not yet a full recommendation. And the spec, which I'll link in the slide, and they'll all be online after this, the spec is a fantastic resource for getting that in-depth technical information that you're craving about WebRTC, how it's made, like the underlying technologies behind it, and how it should be implemented. It's very good for getting in-depth into the API structures. If you're not into that sort of hardcore technical stuff, then you can look at the webrtc.org site. It's a really good resource for slightly more human-readable sort of information about the project and the technologies and the underlying architecture that's supporting it. So things like the codecs involved and stuff like that. And they've also got a really good FAQ to go to when you just want to start asking questions. So we already have real-time communication technologies in the browser today. We have WebSockets. So why would you want to use WebRTC? At the most basic level, WebSockets and WebRTC achieve completely different goals. So WebSockets is mainly about providing a reliable, real-time data connection in JavaScript. It's a really good way of opening a sort of socket connection and just being able to push data back and forth, avoiding those sort of long polling and AJAX. On the other hand, WebRTC is much more about providing a network infrastructure for streaming media. So it's a very different use case, although they do kind of cross over slightly, as we'll see in a moment. Communication methods such as WebSockets also require a server to act as a middleman. So basically acting as a proxy to pass messages back and forth between the different users that are connected to whatever service you've created. And the problem with this middleman approach is that you have to wait for your messages to reach the server, so before they can be passed on to the recipient. And then you have to wait for the recipient to do something, send it back to the server, and then eventually you sort of get it back at some point in the future. So if both users had a latency or a sort of a time to connection between them and the server of 20 milliseconds, which is conservative, a round trip would, between the two users, would take about 80 milliseconds. And that's nearly a tenth of a second just to send a message back and forth. On the other hand, WebRTC is a peer-to-peer connection directly between two browsers. So there's absolutely no middleman. Now, there's a slightly sort of blurriness to this, and we'll touch on that in a moment. But just think about it as two browsers being connected directly together without a server. And what this allows you to do is it allows you to send those messages directly without hopping through that server. So if the latency, again, was 20 milliseconds between these two users, then the round trip would take just 40 milliseconds. So you're effectively halving the time. Now, your mileage may vary when you do this sort of in production environments, but that's kind of the concept behind peer-to-peer. So another big draw to WebRTC is that it primarily uses a network technology called UDP. So it's a method of sending data across the network in an unreliable fashion. So in comparison, for example, with WebSockets and HTTP, it uses TCP, which is a reliable method of sending data. So without going into too much detail, UDP is a lot faster than TCP, basically because it doesn't worry about things like the ordering of the messages and error correction. And because of this, you wouldn't want to use UDP to send important data that needs to be received in order and sort of incomplete packages, things like websites. So instead, UDP is commonly used in situations where you only care about the very latest piece of information. And you have no need to wait for the data being sent in the past to come through correctly and in full. So voice over IP and multiplayer games are perfect examples of this being the case, because they only really care about where, for example, in a game, where the player is right now at this very moment. Wherever they were in the past is irrelevant now, so they just care about what's happening. So UDP allows you to get much faster network connections. And WebRTC is the first time UDP's been really available in the browser without plugins. So it's quite an exciting time for developers. I mean, myself, I like just playing with these technologies in general, and there's a lot of stuff I can see WebRTC being useful for beyond simple video calls. So let's have a look at some of those use cases now. The ability to use this peer-to-peer connection is appealing, but what else can you do with it? So, as I've already mentioned, the most common use case is video and audio calls, a la Skype. So this seems to be the approach that most people are selling WebRTC as today, which is fair considering that's kind of what it's been marketed as, even from the technical level and from browsers. But WebRTC is way more than that. The ability to do screen sharing is something that WebRTC could do. It's very similar to the concept of just sharing audio and video through a call. We'll have a look in a moment. Chrome are actually looking at this and having the ability to have the browser allow screen sharing via WebRTC, so that's pretty cool. There's also things like collaborative activities. So anything that two or more people can do that doesn't really need a server in the middle. So like collaborative writing or coding. It's another area where WebRTC is gaining a lot of interest, and a lot of people are starting to use the technology in that way. Sort of mentioned it briefly with the UDP thing. Multiplayer games is a massive area that's going to hugely benefit from WebRTC, primarily because of the UDP and the ability to send these unreliable network messages. But it's actually the same technology that a lot of games use outside of the web. So it's kind of the web's been the sort of the poor sibling that's not been able to have this opportunity before, and at least outside of plugins. And now we do have that. So it's going to be interesting to see the kind of games that result from this that don't need a server in the middle to be played. So we'll actually look at one of these games in a moment and just sort of see what people are doing with that today. A slightly more interesting use of the technology, which I've not really seen much of yet, is peer-to-peer file sharing through the browser. So this is the ability to like quickly send a file directly to a friend, not via a server, just straight to them, without leaving the browser. It's kind of an appealing option. Now you could just do standard file sharing. There's probably ways you can embed these into sort of the applications that you're using and have WebRTC as the underlying powerhouse behind it. I can also imagine the possibility of something like BitTorrent in the browser using this kind of technology. Now, there's a lot of loopholes to sort of jump through or hoops to jump through even, to make this happen, but people are talking about it and people are looking into it, so it's very, very interesting. And something I'd never really considered before as well is the idea of using WebRTC to create a peer-to-peer CDN amongst your website visitors. It sounds a bit weird and abstract and kind of creepy, but the idea of sharing the serving of assets amongst a network of peer-to-peer connections is incredibly interesting, beyond the sort of moral implementations or implications even of that. We'll actually look at a couple of implementations that are using this today and show you how it works. And then something that flips the common approach of WebRTC is the actual idea of using it to remote control other devices. So in this case, you're actually connecting another browser connecting your browser to a device that you own. So instead of connecting from your device here to someone else's device somewhere in the world, you're actually just connecting from my phone here to this laptop here. And that way you can actually use it as a remote control to do things like acting as a game controller. For example, if you had web technologies running on a console or a TV, or if I wanted to use my phone to control a game that I was playing on the desktop, I could do that with WebRTC. So those are a few of the use cases. I'm sure there's many more. Those are the most sort of common and most popular at the moment. So let's have a look a little bit at the APIs involved in WebRTC. So there's three main ones to sort of get your head around. And let's quickly take a look at each of them. The first is media stream, which is commonly referred to as GetUserMedia. So this API basically gives you the ability to access media data streams within the browser. So webcam, audio from the microphone, that kind of stuff. You may have seen a lot of GetUserMedia demos and blog posts and that kind of stuff around. Media stream has been around for a little bit, particularly GetUserMedia. So most people have at least heard of that one. The thing with GetUserMedia is that it's commonly referred to as WebRTC support. It is not WebRTC support. So if you hear a browser say, or a project say that they support WebRTC, and all they actually do is have a local webcam feed or a microphone input, that's not actually WebRTC really. It is kind of one of the APIs involved, but it's not WebRTC. So the kind of things you can do with GetUserMedia is kind of cool. This is an example of me mucking around at home with a demo that someone else produced, which basically takes my webcam input, runs it through Canvas, gets pixel data, and then converts it into ASCII characters and outputs it in the DOM. And you just get sort of your face in text. It's kind of cool, kind of weird. But it's a cool way of like interacting with devices that you wouldn't normally have been able to interact with JavaScript. The second API, which is arguably the most important one, is the PeerConnection API. So this API basically gives you the ability to make peer-to-peer connections and attach media streams, so that the webcam and audio feeds, to that peer-to-peer connection and share that with someone. So this is basically the crux of what WebRTC is all about. Combined with that, there's also the data channel API. So this is basically the ability to forget about media, so forget about video and audio, and just send arbitrary data across a peer-to-peer communication or peer-to-peer connection even. So if you just want to send text or binary messages, that kind of stuff, you would use the data channel API. So those are the main APIs involved. Let's have a quick look at the support for them. So the desktop support is pretty good, actually, even though the technology is fairly new and it's a bit in flux at the moment. Firefox supports WebRTC by default in version 22. So that's currently going through the testing phases in the Nightly and Aurora branches. That'll soon come into the public version. So probably around the end of June, because they've now got a 6-week cycle. You can actually play with this now if you take the Nightly and Aurora branches and play with WebRTC today in that browser. Chrome, on the other hand, has WebRTC support by default in the public version today. It doesn't have data channel in that public version just yet. So Chrome Beta actually has the data channel API available, but you have to enable it behind a flag. I believe Canary's actually removed that flag now. So slowly but surely, that will fall into the public version as well. Opera only supports the ability to get video and audio via GetUserMedia, so it's not WebRTC. IE has no WebRTC support natively, surprise, but support can be added if you use Chrome Frame. So kind of not really IE, but hey, you've got to have Chrome Frame. Mobile support, which is arguably the most interesting aspect of WebRTC, I would say, is OK. It's not as good as desktop, but we'll have a look at it now. So Firefox and Android has WebRTC support. It's currently behind a config flag, so you have to turn it on and sort of play around with it. And it's very early days, but it's your mileage may vary with it. I had a bit of trouble getting it running in one of the demos, but I've been assured that it does actually work. The implementation is changing quite a lot, so just be aware that things will change a lot. There's a lot of the Hacks Mozilla blog is a good place to sort of keep up to date with what Firefox is doing with WebRTC, particularly on mobile. And I know that they plan to firm up this mobile support in the sort of coming months, and I know they're also thinking about doing WebRTC for Firefox OS as well, which is pretty cool. Chrome on Android has WebRTC support, again, behind a config flag. This one seems to be quite reliable, and you can certainly make a call between Chrome Mobile and the desktop browsers as well. Had a little bit of trouble doing it on the network here, but you can do it mainly. That isn't a problem with the network here or a problem with Chrome. There's a lot of underlying sort of issues with making WebRTC connections that we'll touch on briefly. But the ability to make a call between mobile and desktop is pretty cool indeed. Opera Mobile, again, only has support for GetUserMedia, so not really WebRTC support, but worth mentioning. And I believe BlackBerry has GetUserMedia support as well. So I kind of touched on the interoperability of these implementations in the various browsers. The sort of cool thing about WebRTC would be the ability to make a connection between two different browsers, and it wouldn't be that useful if you couldn't do that. Unfortunately, until very recently, the situation sort of wasn't very promising, and you couldn't actually make a call between two different browsers. However, earlier this year, not too long ago, it was announced that a WebRTC connection could be made between public builds of both Firefox and Chrome. Now, this may not sound like a massively exciting thing, but it's actually pretty big news. It was co-announced by both Chrome and Firefox in the respective developer blogs, which is kind of rare to have a joint announcement like that. Yeah, it was nice just to see the differences between the browsers put aside. I mean, I've got background in Mozilla, and actually behind the scenes, the two browsers work together quite a lot, and it's all very friendly. But from the public point of view, it's also a bit of a competition, and there's a bit of fighting. It was just nice to see that put aside, and there was a blog post announcement with a video of a Chrome guy and a Firefox guy calling each other with big logos in the background. It was kind of funny. Bit of a PR stunt, but it was cool. So hopefully, if all works well, I'm just going to show you a quick little demo of WebRTC working. Okie dokie. So you should be able to see my ugly mug. There we go. And what I'll do is, this is just using a demo that the Chrome developers put together to test WebRTC and also do that interoperable connection between Firefox and Chrome. I'm actually just going to launch it in 2 tabs in Chrome. It's completely replicating you connecting to someone else anywhere in the world. It's just easier to do that in two browser tabs. So we'll just open that. There we go. So that's 2 different browser tabs, 2 different feeds, and the remotely connecting using WebRTC. So although it's still in one computer, it's hard to grasp the concept. It's not using a server to do this. It's going straight UDP between peer-to-peer, between the two tabs. It would have been a lot more glamorous if I could do a demo with someone else, like in Australia or something, but we'll forget about that one. But yeah, so that's a demo of it working. It's pretty simple. I mean, that was just a video and audio call. And the underlying code isn't that much more complicated as well. So let's actually take a little bit of a look at how to implement this, at least something similar to that demo you just saw just now. So the most basic API to look at first is the media stream API, specifically that GetUserMedia method. So what we're going to look at is a basic implementation for just accessing the webcam. So it's like I said, pretty basic, but it gets the job done. The only other thing you need here from the code, from the JavaScript code at least, is a HTML video element to attach the video stream to. And it's also worth pointing out that although you can't see it in the code here, we're just using a simple polyfill that the Google guys created to abstract away the prefixes currently being used for the WebRTC APIs. But that's pretty much it. So you'll also need to run this through a domain because you'll hit a few security issues if you try and run this from the local file system, because it's a little bit creepy if you're trying to access people's webcams. So they need to be able to make the user aware of this and where it's coming from and all that kind of stuff. Things get a little bit more complicated when you want to look at the PeerConnection API. But once you understand the process, it's not too bad. So we'll first take a look at an example that makes a local PeerConnection between a single browser page. So a little bit like what you saw, but it would just be in one tab. So this is a good way of looking at the code and how the connections are made without actually worrying about the extra functionality to make a call between two completely separate browsers that don't actually know each other beforehand. So in this example, we're making use of that simple polyfill again. So just bear in mind that's why we're not using any browser prefixes. And we're also sort of ignoring the HTML, as it's most important to understand the JavaScript here. But the HTML is really just a couple of video elements that we're attaching the streams to. So the first step here is to call the GetUserMedia method. This is attached to the navigator object. And we then just connect that local stream that we get from GetUserMedia to a video element so you can see yourself, because it's kind of useful to be able to see yourself. And then we next just store that reference to the local stream so we can access it later on. At this point, we haven't really achieved anything more than that previous code example you saw. You're basically just going to be seeing yourself in a video element on the web page. So once we've got the webcam and audio set up, what we're going to do is then start the process of creating that peer connection. So firstly, we call the RTC PeerConnection method and basically pass it an empty variable. Now, you could actually fill that variable out. It's just options for what are called turn and stun servers. And this is allowing you to sort of bypass firewalls and have particular methods and approaches to try and avoid connection issues that you might have with firewalls. Now that's the underlying networking and all that kind of stuff is a bit beyond the scope of this talk, but that's where you would access that information. And that's all detailed in the specification and the WebRTC.org website as well. The next step is to set up an event handler for what's called an on-ice candidate event. And this is basically to work out which methods the browser can best use to make a connection. So it will be basically a list of IPs and connection methods that the browser could possibly use to make a connection from this computer to another computer, or this tab to another tab. Yeah, it uses a thing called ICE, which is kind of attached to the turn and stun thing, and it's a way of tunneling through network connections and working out the best way to do that. It's a huge networking theory, and I don't fully understand it, but I've been told that it's all abstracted away in the API. Well, it is all abstracted away in the API, so that's pretty cool. But I mean, if you really are interested in that, then again, look at the specs and stuff like that. So what we then do is call RTC PeerConnection again and use that as our remote connection. So the one we used previously, we're going to use as our sort of local user. The next one is the remote user, the one we're going to connect to. So we create a new RTC peer connection, and we again set up the on-ice candidate handler to deal with that. And what we're then going to do is set up an on-add stream handler as well. And what this basically does is lets the remote connection know when the local connection is added, like a webcam or a audio feed. And then we can sort of work out what to do with that after them. So from there, what we then need to do is actually add the local webcam stream to the feed. Webcam feed to the stream. So we call the the add stream method on the local peer connection. A lot of peer connections here. So finally, what we then do is we call a method called create offer. Now, this is the start of a process that basically is a handshake between one user and another user to say, hey, I'm ready for a connection, and the other one would return that and with an answer and say, yep, I'm ready, let's go, and they make the peer connection. So the first step in that is calling the create offer method on the local peer connection, and just passing it a handler to deal with the returned information. Now, the returned information is what's called a session description. Incredibly exciting stuff. A bunch of numbers, a bunch of gobbledygook. People do understand that, apparently. There's a big Wikipedia page about it. Effectively, all you need to know is that's all of the information that WebRTC needs to know which kind of media to be streaming, how to make the connections, and all that kind of stuff. If you get that kind of information, you know you're on the right track. Don't worry about understanding it fully. So moving on slightly, this is what the on-ice candidate handlers look like for the local and the remote connections. So local on the top, remote on the bottom. And basically what's happening here is we're getting that list of connection methods and saving that on the opposite connection. So the local one's being saved on the remote, and the remote one's being saved on the local. So they kind of know how they're going to sort of get in touch. But even though we've done that, we're still not quite ready to make that connection. So the last chunk of code allows us to successfully hook up these two sort of peers together and have that connection going between them. So we're just going to tidy up some of the loose ends. So the first thing we need to do is set up a handler for the create offer method. And this is where it's called got description 1 here, but this is actually a demo taken from HTML5 Rocks. And this basically just handles that session description you saw. So what we're going to do is take that return session description, and then we call a method called setLocalDescription on the local peer connection. So that first user who's trying to make the call, we just want to store that session description on them. And then what we do is we do the opposite on the remote connection. So with this local in one browser tab version of WebRTC, you don't have to worry too much about sending that over to the remote user because it's all in one script. So what we do is on the remote peer, that second peer connection we're doing, you call set remote description and pass it that session description that was just given to us. So at this point, we're nearly ready to make that connection between them. We just need to respond to that first offer that was created by the first user. So the next step is to call the create answer method on the remote or the second peer connection that we created. And again, this will give you a session description back. So from there, we jump into the got description 2 handler. And that's effectively doing the same as what the first one was doing. Now, obviously, you can optimize this. This is just a basic demo of what's going on. What we then do is just do the reverse of what we did with the local peer. So we call set local description on the remote peer and give it its own session description. And then we call set remote description on that first local peer and give it the new session description from that second peer. Just bear with me with this. So what we then do is actually have this connection already created. So once we've made that offer and answer dance between the two peers, which in reality is not much code and quite simple to do, you actually have a connection between them already. You're not going to see anything because we haven't set up the handler for the streaming webcam. So the last thing we do is just have the handler for the remote stream. So that add stream handler, we basically deal with that now. And what happens is when the second peer gets access or gets notified that there's a stream being sent by the first peer, we just basically add that to a video element, and there you go. You've got two people. You've got your local version, and you've got your remote version. These two people just sort of sitting in your browser tab. Now, the problem with this approach is that it only runs within a single browser window. So most of you who want to use WebRTC will want to make connections between remote browsers or two different devices or what have you, kind of how you would normally use it. A full code example of remote WebRTC is kind of beyond the scope of this talk, just because there's a ton of code. But basically, what I'll do is I've provided some links in the slides to be able to do that. And instead, what I'll talk about briefly is the concept of what they call signaling, which is the discovery and the connection of remote browsers or devices that want to connect via WebRTC. So with that local peer connection demo that we just had a look at, which arguably the code is quite simple, the act of the peer discovery, so knowing the local and the remote peers to connect, that wasn't really needed as it was all done in the same script and we didn't have to worry about anything and we could just list it all out. With a full remote peer connection, the first step is actually to use a server to discover the other peers that want to make a connection to you. So basically we use this server to work out which computers want to connect to each other because we just can't work that out at the moment locally. So the common techniques used to do this include like using a room name or a unique identifier that you can give to another user, and then they can both sort of tell the server that they're connected, or at least they want to join the same room, chat room, for example, and then the server can do the dance to make them connect together. So once you know which two devices or which two browsers want to be connected together via WebRTC, what you then need to do is perform that handshake. So basically send the session descriptions from one another via the server back to the other peer that they've been paired with, and do that create offer and create answer dance so you can actually connect the two together. Now you've already done this with the local demo that we just saw, but it becomes a little bit more complicated when you do it remotely. And the common approaches to do it are basically using like Ajax or WebSockets to connect up to the server, and then the server knows who to send that back down to on the other end. And to be clear, all that's happening on the server here is it's just acting as a messaging proxy, basically. And this is the only step that requires a server. As soon as this is done and the handshake has been made, then the two peers will be connected directly via peer-to-peer UDP. And at this point, the server is no longer required, and you've got a WebRTC connection up and running. So it sounds quite simple in theory, and it kind of is thanks to the APIs involved. Like there's a ton of networking stuff going on under the scenes, behind the scenes even, particularly with that ICE stuff. And yeah, I mean, it's just great to have this API to actually abstract that away. That's kind of why I love JavaScript APIs. So that's sort of an overview of Peer Connection API and how to actually connect peers together using it. Now, there's also the data channel API, which I mentioned, which is slightly different, but it relies heavily on the Peer Connection API. And this is basically so you can send that arbitrary sort of binary or text data or whatever you want to send over a peer-to-peer connection. And to implement that, you basically just need to have a peer connection already being set up. And what we're going to do is make a call to the create channel method on the local peer connection to spin up a new data channel. And we're going to pass it a label, so basically just a name and some options. In this case, we're using some options with reliable false to force it to be a UDP, unreliable data connection. The idea is that eventually you'll be able to use reliable TCP connections with the data channel, so you could have like a reliable data sort of stream happening on top of a unreliable audio and video call. So it's kind of interesting to have that, the two sort of various networking methods combined. So what we're then going to do is set up a handler on the remote peer connection to listen for a data channel connection. So it's going to listen for that first peer connection to make that data channel. And then when that data channel is received, what we're going to do is just store a reference to it and set up a handler to listen for incoming messages. And at this point, it's very, very similar to WebSockets. So you just listen for an on message, and you also can send messages using the send method. And from there, it's pretty simple, and that's it. There's a bunch of other methods and events that you can listen to as well to do a bit more like closing the connections and error handling and stuff like that. I've left that out for the sake of brevity, but you can look at there's a good HTML5 Rocks article on this, and there's obviously the specs and stuff that you can look at to get a much more fine-grained sort of overview of the APIs and the events involved. So now that we've seen how WebRTC works, let's take a look at some of the projects that are using it today. And arguably, this is where it gets quite interesting. So the first one is Towtruck by Mozilla. Has anyone heard of this? Cool. OK, more people that have used WebRTC, so that's good. It's basically a way of collaboratively browsing or editing, having chat and voice all sort of within your browser. So hopefully I'll be able to sort of show you roughly. There's my face again. That's not good. What's going to happen? So what we're going to do is, this is an example Towtruck page. I'm going to refresh that. I'm going to start Towtruck. There we go. So what I do is basically just give another user this URL. And then I should, if it all works, there we go, be able to join the session. So you can see there's the mouse of the other user in that tab. So if we go back to the other tab, I can move around. So, I don't know, let's scroll down here. I'm going to leave my mouse down here somewhere. Go back to the other one. You can see down here that the mouse is now down here. So if I scroll down, you can see in real time where the other user is. So it would be a little bit better if I had someone else up here doing this with me. But what you can also do is have instant messaging happening at the same time. If I joined another page, then it would tell the other user that I've joined another page and do I want to follow them, which is kind of creepy, but allows you to collaboratively browse the web together. So it's a really interesting use of WebRTC, and I kind of like it. There's also a lot of chat applications. So Conversat.io is an interesting one that basically allows you to have small video chat rooms. There's not much more to it than that. You can basically just go straight up onto it right now and have a WebRTC sort of chat room there with other people that have WebRTC enabled. Peer.js is one of a growing number of libraries that sort of abstract away the complexities of WebRTC. This one is particularly involved with the data channel framework. The data channel API. And it offers developers free signaling servers, so all that process of sort of doing the handshakes and all that kind of stuff, it does that for you. It's abstracted that away with the API. And they actually offer, like, if you have up to 50 concurrent connections, you can get that for free. So it's a really interesting way of just sort of getting to play with WebRTC today if you just want to have a go with it and not worry too much about setting up the server infrastructure. There's also things like Twellophone. So this is basically a Twitter-powered video and text chat powered by WebRTC. So you use, obviously, you sign in with Twitter, and you can access all of your contacts, and you can use them as an address book to call other Twitter users. And if they have WebRTC enabled, then they can basically use that to create a video communication channel between these two Twitter users. Interesting. A lot of people doing video and voice chat. Twilio. I'm sure a few of you have heard of Twilio. They are an increasingly popular service that allows you to make and receive real-world phone calls programmatically. So basically, you can make phone calls and receive them from a browser, which is pretty cool. And the way they're allowing you to do that from the browser is they're using WebRTC, which is kind of a novel way of using it, because you kind of think of WebRTC as making a call between like two browser tabs, or one browser on a mobile phone to another browser on a desktop. This is about calling real phones from the desktop using WebRTC. Calling real phones in the real world. They're not using a browser, they're actually using like proper dialing mechanism. So Twilio is a really interesting approach to that. There's other companies that are trying to do a similar thing. We'll touch on a couple of those in a moment. So going back to what I mentioned at the beginning about the distributed CDN amongst website visitors, there's a couple of people looking into that right now. One of those is Peer CDN, and it's basically offloading your website assets amongst that peer-to-peer network of connected visitors. They don't actually have a demo at the moment, but they do have a really interesting video which outlines what they're trying to do and how they're sort of overcoming the creepiness and the security aspects of that. It's a very, very interesting way of using WebRTC. I'm not quite sure how it will be received by users, like particularly if they don't know what's going on, and all of a sudden they've got like this massive uploaded stream where they're uploading these videos that they've been watching earlier, and they're just going to some random person on the internet. Because right now the data channel API doesn't actually give you any warnings when it's making a connection. Another one that does have a demo, fortunately, is PeerKit. This is a much more simple one, and I'll show you a quick demo of it running, actually. So, find the thing. There we go. So what we do is we have one browser tab with PeerKit open, and we'll just refresh the page. So what we've done is we've actually downloaded that image from the server, as it says. We can then open up a new tab with the same thing. And because we had that tab already open before, that image was actually sent to me on this tab from the other tab. If that was another user somewhere else in the world, the same thing would have happened. I would have been given that image from them rather than being streamed down from the server. So whether that's saving bandwidth for whatever reason you want to do that, or just because it's cool or creepy, up to you. It's still very interesting, and it's being sort of implemented today with these libraries, so you can actually use that, take that JavaScript API and actually do something with it today. Going to multiplayer games, Banana Bread is a project that Mozilla's been working on, which is basically a port of a native game using WebGL, using their mscripten sort of conversion system. And this is a peer-to-peer multiplayer version, which is using WebRTC. This is quite a new one. I'm not quite sure if actually if they've released the demo for it yet. But this is just a quick video of them actually playing around with it in the Toronto office and having a muck around. But it's interesting to see people using that right now. And there's a lot of games that I can see taking WebRTC and using it in a similar way, particularly if you want to have like local games, for example, on a local network rather than worrying about playing people across the internet. So for example, silly things like the presentation yesterday, you could have Scrabble boards. You've got the main Scrabble board in the middle, and you've got WebRTC connections into that main Scrabble board that are showing something slightly different, the whole idea of asymmetric gameplay and things like that. You can do those kinds of things with WebRTC. It doesn't have to be just traditional peer-to-peer multiplayer. There's a lot more to it. So this is just a screenshot of a HTML5 Rocks blog post about the Chrome support or experimental support at least, for sharing browser tabs. So it's basically just a streaming video of what's going on in a browser tab. Kind of cool. So you can, like, I don't know, do tech support for someone, or like watch them browse a website if you want to do that. But still kind of interesting to see that browsers are implementing these experimental features. Phono is a jQuery plugin for making and receiving phone calls from the browser. Very cool. It's also ridiculously simple as well. It's being used by AT&T actually within their att.js, which is effectively powered by Phono. But it has the att.js stuff has a few extra bits and pieces sort of included, so you can do management of the calls and stuff like that. I believe because they have a partnership with Ericsson as well to use a bunch of APIs that they have. But this is sort of maybe a little bit more simplified version of what you can do with Twilio to be able to make real calls to real phones using JavaScript. I mean, it's kind of, I would never have imagined saying that like a few years ago, but apparently you can do that now, so it's kind of cool. There's also many, many more sort of chat applications. So there's OpenTalk as well, which is another one. They're aiming to do a lot more sort of with, for example, archiving of chats, like video chats and that kind of stuff. Now, they don't yet have that implemented in WebRTC, but that's going to come soon enough. So you have like screencasts and sort of maybe like Google Hangout style things, and you can record that and then save that off somewhere else. A slightly different approach is File Hangout, which is basically a way to experiment with data channels for sending files amongst multiple peers. So it's a little bit like BitTorrent, but it's not quite as advanced as that. But basically, you can connect anonymously-ish to this example and just send files amongst each other without going via a server. It's kind of cool, and it's really quick. There's also something called Squiggle. Really cool name. Basically a collaborative dashboard for remote working, so allowing you to see each other and share resources throughout the day. Now, I used to remote work while I was at Mozilla, and I don't think I would have wanted to sort of see everybody's face on a webcam all day, but what you can do at least is do that maybe for meetings and things like that, and share the resources that are happening through the meeting on that sidebar on the right, and then sort of do something with that later, whether that's archived. It's up to you. Now, something that was really cool was a Ericsson Labs 3D WebRTC demo. Now, this Ericsson Labs are basically pushing WebRTC quite far. They were involved heavily in the early adoption of WebRTC and the technologies involved to make it happen. And they basically combine the output from a depth sensor and synchronize it with a peer-to-peer video call. And if you wear, well, you can either do two things. You can either wear special goggles, or you can actually view it in WebGL and basically see this live call in 3D, like this dude moving around. Bit weird, but kind of cool. And then there's also like simple stuff like collaborative code editing. So Codasium is a way of doing that, or it's at least an approach that's trying to look at that. They're marketing it more towards like programming interviews, but regardless, you can sort of collaboratively edit code and then sort of do something with that afterwards using WebRTC. Something that came up the other day, which was interesting, was something called GrimeWire, which is a sort of being marketed as an operating system built with browser technologies. And they say it uses WebRTC for connecting some of the components of that operating system. I'm not even sure how they do that yet, or what, or why, or what on earth is going on. But it certainly sounds really cool. All the links for these kinds of things are in the slides, which I'll give the link to at the end. But it's worth checking out if you're interested in the technology and what's being done with it. So I hope that I've managed to pique your interest a bit in WebRTC. I know it's a bit of a dry topic. It's fairly new. It's a lot of networking involved and a lot of things you probably didn't want to have to worry about. But it's fun, and it is worth experimenting with. And as complicated as it may look or sound, it is quite easy to play with once you get your head around the concept involved and the ordering of the messages and stuff like that. So yeah, there's so much more to it that you can do that beyond what I've mentioned today and what people are already doing with it today. There's way more to it than that. So I'm particularly interested to see what people do around mobile phones and using those as remote devices and, I don't know, hooking up sensors with WebRTC, things like that. So I'd love to hear and see what you're making with it. So definitely ping me on Twitter if you do something like that. And I'd love to sort of talk about it and talk to you about it as well. And yeah, so my name's Rob Hawks. You can follow me on Twitter @RobHawks. I blog about everything I do on rawks.com, and there's a few links to the projects that I'm working on. And the slides are already on SlideShare at slideshare.net/RobHawks. And that's pretty much me, so thanks for listening.
Thanks, Rob. I actually don't think that's dry at all. Like that touches on some of the stuff that we were like playing around with a little bit yesterday with like the multi-device interactions and stuff like that. I think that's fascinating. Some of the things that you were saying, like the remote control and things like that, those are things that people are also experimenting with WebSockets for, right? So the primary difference is that WebSockets needs a server, or is that basically the gist?
Yeah. So yeah, the gist is that WebSockets needs a server continuously. It doesn't matter where that server is. It could be locally on the network, but it's a little bit more tricky to do that. I did actually experiment previously with having a WebSocket server set up in a browser extension, so you could have like a local game server. But nice. WebRTC doesn't need that. It just needs an ability to discover peers. So you could bypass a server completely if you use maybe like a QR code between two devices to make that connection between them.
Yeah, it's almost like it's really more of a true direct communication instead of having that middleman sitting in between.
Yeah, exactly that.
Super interesting. So it's what Firefox, Chrome has some. So Apple and Microsoft, right?
Right.
I'm curious with Skype sitting there and with Apple's own stuff and Apple just being Apple. Has there been any hints that could be coming in either of those?
I'm not too sure about Apple because they do keep things fairly quiet. With Microsoft, that's quite an interesting one with Skype. Now, there was talk a while ago about having WebRTC in Skype, but Microsoft are kind of keen to explore their own options with that. So there's a bit of an argument at the moment between the specification communities about the spec that they're supporting and the Microsoft specification that they're trying to push as well. And it's involved around all sorts of different things like the codecs involved. And it's a discussion way above my head, but Microsoft are kind of pushing their own thing, and hopefully they'll relinquish that and go with what everyone else is using at the moment.
Is that getting into the whole H.264 versus the other format and all that kind of junk?
There's all sorts of stuff, yeah. I think Microsoft, they're worrying that we're going to focus on just one codec, which is the version at the moment. They kind of want to have a bit more abstract where you don't have to set yourself one codec right now, but then it gets a little bit more complex.
Yeah, and you can, it sounds like is Mozilla it's kind of like almost an incremental approach to kind of adding in a lot of the things that they want to do with WebRTC, right?
Right.
Which partly has to do, I'm sure, with you kind of hinted and alluded to how much is going on behind the scenes of in particular the PeerConnection stuff, right?
Yeah.
Are there any, there was a few questions about potential security issues and stuff like this, but I'm sure that's an issue, but is that being addressed to some extent?
Yeah, it's so the connections are encrypted and all that kind of stuff. So you've got the basics covered. There's also the permissions dialogues that appear. So for any website that isn't using SSL, then you have or HTTPS, you have a dialog that always shows up every time you refresh the page that tells you that the webcam or audio wants to be used, and you have to allow it, and you can't remember that. If you use HTTPS, you can actually click on Always Allow. So you you hope that it's a more trusted site, and you have that option to trust that website with your
and then you don't
permission.
get prompted ever again on that.
And you don't get prompted ever again, and you can always change it. Yeah, it does. Yeah.
I think people would just, especially after Max was up here demonstrating how you could override the local storage thing and just plug everybody to just kill their device. I think that's the security thing comes into play. Because you could see theoretically, especially with the ability to do the peer-to-peer CDN or the CDN and everything else that you're talking about, where that could theoretically, if it wasn't locked down pretty well.
Yeah, the data channel one's a little bit worrying because you could basically do the same sort of thing. You could probably stream a lot of information down, and where does it go? I mean, you can stream massive files at the moment. So I'm sure that'll get looked into. And there's also a little bit of issue with mobile devices and how they let the user know the permissions dialogues in a better way than on desktop. And also what happens when they leave the browser tab open, but just sort of sleep the phone. Do you keep the webcam on? How do they know the webcam's on? There's no light. All of these different things like that.
Oh, fun. Yeah, that sounds exciting.
So you don't want to be
Yeah, that's a whole other topic, though, isn't there?
Exactly.
A whole permissions thing.
Yeah. The browsers are talking about that now and trying to work it out.
Well, very awesome stuff. Thank you.
Thank you.